So looks like we've got a slightly longer question now. We've got 10 marks here. We've got a sketch of something that looks a bit like a negative cubic. Let's quickly read. Figure 5 shows a sketch of the curve. Crosses through the origin, that's been represented in the sketch, and it crosses the x-axis at the points A and B. Given that f dash of x, so that's something to watch out for, we're being told f dash, the gradient function, which you could also call dy dx, is k minus 4x minus 0x squared. K is a constant. Okay. Show that C has a point of inflection at x equals minus 2/3. Okay, so I put a reminder up on the side. Point of inflection, we need two things to happen. We need the second derivative to equal 0, and we need the second derivative to change sign, so it needs to be maybe negative on one side and positive on the other, or vice versa. So we're going to have to check both of those things to fully justify our answer to part A. So let's do a bit of work up on the side. We need to start by finding f dash dash. So for part A, we're already given f dash. The gradient function is k minus 4x minus 3x squared. So we're going to differentiate that just once more to get f double dash, the second derivative. K is a constant, so that will differentiate to 0. We don't need to write that. Minus 4x differentiates to minus 4. And minus 3x squared differentiates to minus 6x. So far so good. Now for a point of inflection, we need f dash dash of x equals 0. So that tells us that we want this new function we found, minus 4 minus 6x, to equal 0, which means that x is minus 4 over 6, which is minus 2/3. Which matches the question, so it's very tempting to stop there, but we must check that our second bullet point, does that second derivative function change sign? So let's think about this. This is a value, negative 0.666 recurring. So what we're going to check is we're going to look at the second derivative at a smaller number, so we might round that down to minus 1, and we'll look at the second derivative at a bigger number, we could round it up to 0, and see what happens. So we are looking at our second derivative function up here, and we're seeing what's the value of that at minus 1 and what's the value of it at 0. So when x is minus 1, we substitute that in, we get minus 4 plus 6, which is 2. But when x is 0, we get minus 4 minus 0, which is negative 4. So it was positive on one side and negative on the other. So we do have this change in sign. That means the graph has changed from the convex shape to the concave shape that you can see in the diagram. So now we have done everything to justify the statement that therefore C has a point of inflection at x equals minus 2/3. Okay. So, a lot to write for 3 marks, but it's pretty steady. The math isn't too bad there. Okay, what's next? Given also that the distance AB is 4 root 2. So that's the distance between these two intercepts on the x-axis. There's another intercept here at 0. We're ignoring that one, but we're finding the distance between A and B. We're told that that's 4 root 2, and we have to somehow use that to be able to find the value of missing k. Okay, so if we're now talking about intercepts, points A and B, those are where the function f equals 0. So the points A and B are where f of x equals 0. So we need to talk about f now. We don't know f, we only know f dash from the original question, so we need to integrate that. Remember, integrating the gradient function gets you back to the original function. So let's start by doing that. F of x is the integral of k minus 4x minus 3x squared. So we integrate term by term. K is just a constant, so it becomes k times x. Minus 4x, the x becomes x squared over 2, so we get minus 2x squared. And x squared becomes x cubed over 3, so the 3's cancel, and we get minus x cubed. And remember there's a plus c as well. So f of x, the graph, equals this function here. We need to do something about c, but we know the graph goes through the origin. So the origin tells us that actually c must be 0 in this case. If you substitute 0 on the left and 0 for x on the right, c must be 0. So this function is just kx minus 2x squared minus x cubed. We can summarize that. Now, it might feel like you've done a lot of work and not got any results yet, but we had to do that. To be able to talk about a and b, we need to know the function f. So we had to do that work, and it will be worth some of the 7 marks that are available here. Okay, let's keep going. A and b, these are points where the function equals 0, y equals 0. So we're going to solve this equation for a and b. We already said this at the top. F of x equals 0. So if we scroll on to a bit more space, that means that kx minus 2x squared minus x cubed equals 0. Now, which doesn't look very nice. It's a cubic. Let's tidy it up so more things are positive. X cubed, positive 2x squared, negative kx equals 0. And notice that x is actually a factor here, which shouldn't be a surprise because x equals 0 just tells us that the graph goes through the origin, which we knew. Or, more interestingly, the other factor equals 0, x squared plus 2x minus k equals 0. So now we're down to a quadratic, and the two roots of this will be the roots, the x values of a and b. Now we can't factorize it because of that letter k, so we have to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac will be positive 4k, all divided by 2a. Let's simplify that slightly because there's a factor of 4 in the square root, which will come out, root 4 is 2 when that comes outside. And you're left with 1 plus k inside, all divided by 2. So this is minus 1 plus or minus root 1 plus k. Not the nicest expression, so let's split them up. We've got minus 1 plus root 1 plus k, and we've got minus 1 minus root 1 plus k. Now if we go back to our diagram for a second, b is on the right and a is on the left, so b is the bigger root. So let's look at these. This one must be b and this one must be a. And we were told that BA equals 4 root 2. Okay, so we'll just subtract these numbers to find the distance between them. We subtract them. That length, the minus 1 minus minus 1 cancels. Root minus minus root means it adds onto itself. We get 2 root 1 plus k. That's the distance or the difference between these two numbers. And the question told us that that must equal 4 root 2. We're nearly there. We just need to solve this to find k. So let's cancel a factor of 2 on both sides. So root 1 plus k equals 2 root 2. I'm trying to avoid squaring. Maybe even 2 root 2 is the same as root 8. So 1 plus k is 8. K must be 7. A lot of effort to get there, but we've done it.